Hi everyone. Short date please and learning objective. I think this is probably the date you're doing the work. If not, it doesn't matter. Just write today's date and learning objective. Pause the video and then we will carry on from there. Okay, press play. Right, okay, so first of all, let's have a quick recap on the difference between independent and dependent events. Okay, so say for example I was to roll this dice and I'm going to see the probability of me getting a 6 on this dice the first time, okay, is 1 in 6, isn't it? The probability of me getting a 6 on the dice the second time remains 1 in 6, and the probability of me getting a 6 the third time on the dice remains 1 in 6. So these are independent. These are independent. Okay, independent events. Okay, independent events. Now today the work we're going to be focusing on is our dependent events. Let me just give you an example of that. So dependent event. So let's have a little look. If I am challenged to pick a red card from a pack of cards, okay, I need to pick a red card. So the probability of me getting a red card, I know in a full pack of cards there are 52 cards, and the probability and there are 26 red cards, so the probability is 26 over 52. It's the same as a 1 in 2 chance, isn't it? An even chance. Okay, so that's the first of my probabilities. So I'm going to pick a card, and what do I get? Right, I get a black card. Okay, so now I'm not going to put this black card back into the pack. I'm going to leave this out of the pack, and this is the key when it comes to dependent events. Okay, so I'm not going to put this back in. So now the probability of me I'm going to try it again. I'm going to try again. The probability has changed though, because now there are still 26 red cards in there because I haven't picked any out yet, but there are now 51 cards in total. So you can see the probability has changed. So let's have another go. Okay, so the probability on the second go is dependent upon what happens on the first go. That's the idea of it. Okay, so let's have a go. Oh, it's a red card. So now again the probability for the third time has changed, because now there are 25 red cards because I've just taken one out, and there are 50 cards in total. So it's actually gone back to an even chance. Okay, I'll just do it one more time. So the probability now is an even chance, 25 out of 50 chance. Okay, get another red card, So that means the next time I have a go, I know there are going to be only 24 red cards because I've picked 2 out. It started off with 26, I've picked 2 of them out, and 3 cards have been taken out altogether. So now it would be a 24 in 49 chance. So you can see each time I take a card out, it changes the probability of what will happen next time. So the probability is dependent on what happened previously. Okay, and that's the work we're going to be doing today. Okay, is to use tree diagrams on dependent events. Okay, right. So look at this word statistics. Okay, statistics. Now, if I was to chop these up into little bits and put them in a bag and draw out the letters, okay, what would be the probability that I would draw out a vowel? Let's count the vowels first of all. So there's 1, 2, 3 vowels. So the probability of picking out a vowel is 3, and how many letters are there altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 3 in 10. So you won't be surprised to know that therefore the probability of picking a consonant, so I've got 1, 2, 3, 4, 5, 6, 7 consonants. So I'll just put that as a cons. Is 7 out of 10, and of course I'm bound to pick one or the other, isn't it? So that does make sense. Now let's have a little look at how we would draw a tree diagram for this. But in this case, we're not going to be put the counter back in. We're not going to put the counter back in. So the probability, first of all, okay, is to get a vowel, and I'll just put V for vowel, C for consonant. We've worked out the probability for getting a vowel is 3 in 10, and the probability for getting a consonant is 7 out of 10. Okay. So if we were to pick out a vowel, okay, if we were to pick out a vowel and not put that back in, this changes. This is obviously in our first attempt. On our second attempt, we have changed the probability, okay, because obviously one of these vowels is now gone. Okay, we've picked a vowel, so instead of 3 vowels, there will only be 2. The probability of picking a vowel is now only 2, and again we've obviously lost one of the counters, 2 out of 9. Okay, so that's the probability of getting a vowel. The probability of getting a consonant has also changed. It's not 7 out of 10 anymore. There are still 7 consonants, but of course there are only 9 counters left. So you can see what's happened after the first one has affected the probability of it happening, of what happened in the next time. Okay, let's have a look if we got a consonant first. Okay, I'll just bring those down a little bit, okay, and then the probability of getting a vowel and a consonant has changed. So because we've picked a consonant, so that means there still are 3 vowels left, but there are only 9 counters left. And the probability of picking another consonant, we've lost one of our consonants, so it would be 6 consonants left, and out of 9 counters each time. So hopefully you can see that what happens here will affect the probability of what happens next. Okay. When we've done that, we can then answer some questions on it, can't we? So what is the probability of getting 2 consonants? So the probability on the probability of getting 2 consonants, so again we follow our tree diagram, don't we? So the probability of getting one consonant there, and then the next one there, isn't it? So the probability of getting 2 consonants, first of all, it's so it'll be 7/10 is the probability of getting it the first time, and then the second one, okay, the second time, the probability is 6/9. Okay, so we've got 7/10 and 6/9. Okay, and from here we can work out the probability of that. So we would times them together. I think it's probably easier on this question to simplify this to 2/3. Okay, which is simplifying the 6/9 to 2/3, simplifying the fraction. So 7 times 2 is 14. 10 times 3 is 30. Okay, so we got 30 over 14 over 30. We can simplify that again, and 7/15. So the probability of getting a consonant on the first one and a consonant on the second one is 7/15. Okay, let's have a look at the probability of getting a vowel on the first one and a vowel on the second. Okay, so the probability of getting a vowel on the first go is 3 in 10. We're following the tree, and the probability of getting a vowel on the second one is 2 in 9. Okay, and again we can cross simplify. Okay, so that becomes, we can cross, because we're times them, we can cross simplify this time. That becomes a 3, then we're going to cross simplify here. That becomes a 1. That becomes a 5. So actually the chances are 1 in 15. Okay, you can just simplify, 1 in 15 if you want to. Let's have a look. 3/10 times 2/9, that would equal to 6/90, and that simplifies again to 1/15, isn't it? Okay, so we're just following our tree diagram. The slightly tricky one is when you have to find if asking the question, what's the probability of getting 1 vowel and 1 consonant. Okay, one vowel and one consonant. So again, we're going to come through here. The chances of getting a vowel are 3 in 10, and from there the chances of getting a consonant are 7 ninths, and we times those. Okay, again, we can do a bit of cross simplifying, make it easier. So here we've got 7 over 30, and then we've got to work out the probability of the next one below as well. So this time we want to get a consonant and then a vowel. So we've got 7 tenths to get a consonant, and then 3 ninths for a vowel. Okay, which will give us, we can simplify this to 1/3. So again, will give us 7/30ths. And remembering from yesterday, because we've got 2 different ways of doing, we add these up. Okay, it's a bit tricky, this one. Add these up. So this time we get 14 30ths. Okay, 14 30ths. Okay, and you can simplify that again to 7 15ths. Okay, 7 15ths. Right, okay. Have a little go at, okay, that is quite tricky. Let's have a little go at this question here. Have a go yourself. We will go over it afterwards, so don't worry too much, okay? So a sock drawer has 5 black and 2 red socks. So, yep. A sock is picked out at random and not replaced, and then another sock is picked. So it's a little bit like the previous question. You have a first attempt and a second attempt. Have a go drawing the tree diagram and then working out these 2 probabilities, please. Okay, pause the video, have a go at that, and then we will we'll go over it after you've had a go. But please have a go yourself first. Okay, pause the video and press play when you're done. Right, so let's have a look. The probability of picking out a black sock. There are 7 socks in there altogether, so that would be 5/7, and red would be 2/7, isn't it? Okay, so the probability of picking out a black sock here would be 5/7. Possibility of picking out a red on the first attempt, 2/7. Okay, so this is our first attempt, remember. Okay, and this will be our second. Now, so the probability of getting another black sock will have changed, isn't it? Because we've already had 1 black sock disappear. So that will be, it's only 4 black socks left out of 6 socks altogether. The probability of picking out a red sock, there are still 2 red socks, but there are only 6 socks left. 2/7, okay, 2/7. Again, the probability of there being a black sock, there are still 5 black socks there, but there are only 6 socks altogether, and the probability of getting another red sock would be 1. It's only 1 red sock left because we've chosen one of them there out of 6. Okay, hopefully that's making sense. This is quite tricky. Okay, so the probability of getting 2 red socks. So for question number 1, the probability of getting 2 red socks, well, the probability of picking a red sock first of all is 2 out of 7. Then the probability of getting a red sock again is 1 in 6. We multiply those. Okay, we multiply those. So again, we can do a little bit of cross simplification there. 3. Okay, so it becomes 1 in 21. It's not a problem if we put 2 in 42 because that would just be simplified. Okay, so 1 in 21. So you'd have to do that 21 times to expect to get 2 red socks. Right, so a little go at the next one. The probability of getting 1 red sock and 1 black sock. So this is the slightly tricky one. So 1 black, 1 red. So that would be 5/7 times, there we go, 2/6. Okay, I'll just leave these. So that'll be 10 42s. Then the chances of getting 1 red, 1 black. Okay. 1 red, 1 black, so we've got 2/7 times 5/6, and again it's 10 over 42. Remember, we have to add these up together then, don't we? So 10 42s plus 10 42s, 20 over 42. okay, which again when simplified is 10 over 21. So it's slightly less than an even chance, isn't it? Just under an even chance of that happening. Hopefully that was okay. I'm just going to go over one more type of question before we do your own work. Now you can also have you can have three different choices, and this is and here say for example we had 6 different colored counters, 2 blue, 2 green, 2 red, and we do the tree diagram in the same way, except it's just an extra branch to it, isn't it? So the probability of picking out a blue is 2 out of 6, because there are 2 blues out of 6. The probability of choosing a green, again, is 2 out of 6, and the probability of getting a red is 2 out of 6. Okay, so that's if you get a green, that's if you get a red, and that's if you get a blue. And then from there you would do another one, but this time it would be 3-pronged, wouldn't it? It would be a 3-pronged one from there. So we go there. So the probability now of getting a blue, you've already had 1 blue, so that means there's only 1 blue left, but there's only 5 counters left. The probability of getting a green, there's still, if you've got a blue on your first go, there's still 2 greens there. Okay, but there's only 5 counters left. And the same with the red, 2 and 5 counters. So the probability of getting a blue and a blue would be 2/6 of getting 1 blue, and then 1/5 of getting another blue. Okay, and that would give you 2/30ths. 2/30ths. So we can simplify that to a 1 in 15 chance. Let me just check that's okay. So I rushed through that. Yeah, okay, good. So again, it's exactly the same as another one, but you've just got 3 aspects to it instead of 2. Okay, right, this is the work I'd like you to do today. I know it's quite a long video today. So it's not, I haven't asked too many questions. Can we have a go, please, at these ones are a must have a go at those ones, okay? This is an extension question. I'd like us all to try, please. I'm not going to be too worried if you're struggling a little bit on it, okay? But have a go at that one as well, please. So have a go at these 3, and then we got the 2 extension questions at the end, which are quite tricky, okay? So please definitely have a go at those 2. Definitely do those. Should we do those? Have a go at that one, please. And then if you want to have a go at the extension, you can. Okay, good luck with that. When you're finished, if you could please send it back, that would be great. Any queries, please email me. All right, good luck. Bye.